In previous video, we have learned about the some list functions and search functions applied on the list. We have also seen some classes of evaluation strategies, which include strict evaluation and non-strict evaluation. Lazy evaluation is coming under non-strict strategy. We have also seen that arguments will be evaluated when it is required in the lazy evaluation, and strict evaluation function is only evaluated when the arguments have been evaluated. Also, we have seen some order of evaluation like applicative order evaluation and normal order evaluation, in which the normal order evaluation, it comes under lazy evaluation, in which the arguments will be left as unevaluated and it evaluates in the body of the execution. We have seen that with an example also, in which the applicative order evaluation, the argument will be first evaluated and will be given to the function, and then the body of the function will be executed to give the result. But in case of normal order evaluation, the argument will be given as an argument unevaluated, and in the body of the function, when it is required, it gets evaluated. Hence, some additional work or a calculation is being done. In applicative order evaluation, multiplication is done only once, while in normal order evaluation, it is done twice. So that was the difference in applicative and normal order evaluation. And lazy evaluation, it will be following the normal order evaluation. Then coming to the functions case, there are also strict and non-strict functions, in which the strict functions, it will be undefined, or it will be failed to terminate, or it encounters an error when any of its arguments is left as undefined. Such a function can safely evaluate all its arguments so that its result will depend on the evaluation order. So strict functions, its arguments need to be defined. And in case of non-strict functions, it is sometimes defined even when one of its arguments is not defined. Then functions which allows strict functions will be called as a strict language. So language is said to be strict if it allows strict functions, and non-strict if it allows non-strict functions. So if a language, it always evaluates expressions in applicative order, then the function will be guaranteed to be a strict function, because whenever an argument is undefined, its evaluation will fail. And non-strict language, it cannot use any applicative order. It need to use normal order to avoid evaluating unneeded arguments. So there are some examples that comes under the strict language. They are ML and Scheme. And non-strict languages, it includes Miranda and Haskell. So lazy evaluation, it is one non-strict evaluation strategy which holds the evaluation of an expression until its value is needed. It allows repeated evaluation. It allows the language runtime to disregard sub-expression that are not directly linked to the final result of the expression. It reduces the time complexity of an algorithm. By discarding the temporary computations and conditionals, it is best suited for loading data which will be infrequently accessed. So lazy evaluation, it comes under non-strict language. So which means it can be used in Miranda and Haskell. Scheme language, it is coming under strict language. So in order to apply lazy evaluation in Scheme, we make use of two constructs. They are called as delay and force. So lazy evaluation is like evaluation will be done only when the value is needed. Till that time, it will be left as unevaluated. So it will be reducing the time complexity. So how this lazy evaluation can be done? Using this delay and force, it is given here. So an expression is defined using define function, and the argument is like delay plus A10. So in here, delay, it binds an expression to a particular name. And when is it being executed? When a force construct is being used, it gets executed. Then define A15 means it binds some value to this A, and force expression, when it means that it needs to evaluate the function expression. So in such case, expression is defined as what? Plus A10. A is binded with the value 15. So 15 plus 10, you will be getting the result as 25. So when delay is encountered, it just binds the particular expression to a name. If delay is not being used, then that operation will be performed if this value is known. Since delay is used, thus the expression is bound to a particular name, and that operation or evaluation will be done only when the force construct is being used. Scheme, it uses memorization to save the value of the evaluated expression. So repeatedly, if the force construct is called, then it will be returning the recently executed or the cached value. So what all are the problems regarding the lazy evaluation? As we have learned earlier, principal problem is its behavior in the presence of side effects. So if an argument contains some reference to a variable which may be modified by an assignment, then that value of the argument will depend on whether it is evaluated before or after the assignment. So it will be showing it will be lazy evaluations. It results in some problem based on the side effects. So if it contains a reference to a variable, if any modification that is performed on that variable will affect the other also. If the argument contains an assignment values elsewhere in the program, it may depend on when the evaluation occurs. So an assignment is being done, and this variable, if it is assigned with some value, means if there is any evaluation is given for that variable, then based on that evaluation only assignment will be done. Hence, main problem with lazy evaluation is its behavior related to the presence of side effects. It forces the language runtime to hold the evaluation of sub-expression until it is required in the final result by creating thunks or delayed objects. So if we are creating some delayed objects, means we will be calling it as thunks. That is, with that statement, some expression is given, means it will be treated to be as the delayed objects. So if some expression it need to be left as unevaluated, means we need to create some set of or some group of delayed objects. What it results in sometimes space complexity, increase in space complexity of any algorithm. It is very difficult to find its performance because it contains chunks of expression before their execution. So this chunks of delayed objects, it can be executed only when it is needed. So we won't be able to calculate its performance also, because before execution these chunks of objects it will not be executed. Only during the execution, when it is required, these delayed objects will be executed. Then only we will be able to know its performance also. So in this way, lazy evaluation it affects the system. So how it is compared in Scala? In Scala language, both lazy and strict evaluation can be imposed. How it is imposed and how it is worked, we can see with this example. So here it shows one example with the two functions, less than and more than. So less than 30 and more than 20. So what is the function of this is, you will be given a list of elements, and in that list you need to identify the element that is less than 30 and greater than or more than 20. Those elements you need to identify. So if it is following a lazy evaluation, then in scalar it makes use of a function with filter. Okay, so with filter it just creates a view based on the function. Here a dot with filter of less than 30. So in that less than 30, it checks one by one element it checks. So first in the list 1, the one is less than 30, it checks. Yes, it is less than 30. So what it does, it takes the next statement, performs the operation on the same element. So it checks more than 20. More than 20 means 1, whether it is greater than 20. No. So there it stops. It doesn't execute the next statement. Again it moves to the next element 25. It checks whether the element is less than 30. Yes. Again next statement it will be applying more than, whether it is more than 20. Yes. Then the next statement it checks what it displays the value, that is red, 25. Okay, Q1 will be having 25. Q1 will be assigned to R and you will be displaying the result as 25. Similar process will be given for the rest of the elements also. For 40, it checks whether it is less than 30. No. So it returns a false. So the next statement it won't be taken. There it stops and moves to the next element 5. 5 is less than 30. Yes, it moves to the next statement checking whether it is more than 20. No. Again takes the next element 23, whether it is less than 30. Yes. Whether it is more than 20. Yes. Then it moves to the next element to display the element 23. So the output will be in this format. Okay, so in case of 40, it won't be checking the next two statements. It terminates, which it stops there and reads the next element in the list. Like that, it will be proceeded in case of lazy approach using the with filter function. Same program, if we need to implement using the strict evaluation, means you need to use the function filter. That is the only difference. Okay, if we make use of this filter function, what it returns is, it will be creating a collection of elements that will be satisfying this function less than 30. So given a list of elements, what it does, a dot filter of less than 30. So the whole list will be taken. It will be taking the elements that is less than 30. So a collection of a collection will be created with the elements 1, 25, 5 and 23. Why? Because 40 is not less than 30. It is greater than 30. Okay. So with this you will be getting filter function will be creating a list, and then that list will be given to the that list will be taken for the next statement. So next statement will be applying, that is this more than 20 will be applied on that particular list, that is Q0. And again more than 20 values it will be checking. From that you will be finding that 25 and 23 will be having the values greater than 20, and those will be stored in Q1 and will be displayed on the screen. So this is the result that you will be seeing when you execute this program. First entire list will be compared with 30. From that, those elements that satisfies the condition will be compared with 20, and then the result will be displayed. That is a case with strict approach. So this much is related to the strict and lazy evaluation. Now just comment on the some answers you have to write, examples for the strict language and non-strict language in the comment section. Thank you.